Question 2. Which of the curves shown in the figure is not a trajectory in the gravitational field of a central star at the point x equals 0, y equals 0, marked by the star symbol? Okay, so let's just make a little table. We've got 5 trajectories. So first let's look at 1. So 1 to me looks like an ellipse, and for this to be a valid trajectory, you would expect the star to be at one of the foci of the ellipses. It looks roughly to be there, so I think this one's fine. 2 is a circle, which looks fine to me also. We've got the star at the center of the circle, so that's acceptable. 3 is another circle, where if you compare 2 and 3, you should be able to see that the star is not at the center of 3, it's sort of off center, and that wouldn't be a valid trajectory, because for a circular orbit you would expect the body to be in the center of the circle. Next, question 4, apologies, trajectory 4. This looks kind of hyperbolic, which is what you would expect if something like an asteroid or some astronomical body was passing the star and sort of had enough energy to, I guess, escape the central object's gravitational pull. So yeah, that looks roughly valid. And then 5, again, sort of looks hyperbolic, and for the same reason as 4, also looks valid. So in this case, the answer is E. 3 is not a trajectory. One final thing to note on this question would be that although we've kind of implicitly assumed that circular orbits are possible, because circular orbits are basically a sort of special case of an ellipse, and so it's theoretically possible for an orbit to be circular, but in reality, because of other astronomical bodies that will perturb the orbit somewhat, you're unlikely to ever have a perfectly circular orbit. So because Oxford don't actually release the marks, the mark schemes for this, it's kind of impossible to say what they would give the marks for. But I would put my money on E being the correct answer.